Hey guys, this is Ratios Day 9. Today we are going to start talking about proportion, and we are going to use tables to make ratios. Okay, so when two ratios are equivalent or the same, they express the same proportion. You should fill that in on your notes. Here are some examples. 3 to 5. If we multiply 3 times 2 and 5 times 2, we would get 6 to 10. Those two ratios are equivalent, and they express the same proportion, which is 3 to 5. If we multiply both of those, that original ratio by 3, we get 9 to 15. The second example on your notes is 3/6. So now we have a ratio expressed as a fraction. If we multiply that fraction by 2 over 2, we would get 6/12. If we multiply that fraction by 8 over 8, we would get 24/48. All three of those fractions are equivalent, and they all express the same proportion, which is actually 1/2, or 1 to 2. Okay, so we've got a table in front of us, and we can use these tables to help us to figure out equivalent ratios and equivalent fractions. So we've got John, who needs some buckets of cement and some buckets of sand. So he's going to mix some, I'm guessing he's probably going to mix some cement and sand up and make some concrete or something. I hope I'm right in my memory on that. I'm sure some dad is probably going to know that I don't actually know how concrete is made, but it seems like I remember it being a mixture of stuff. Anyways, I diverge. Okay. Using the same proportions, how many buckets of cement are needed to mix with 30 buckets of sand? So let's just take a look here. Clearly on our table here, we need 5 buckets of cement for every 3 buckets of sand. So if we had 30 buckets of sand, that means that we would have multiplied that 3 times 10, and we need to do the same thing with the 5. And so let's use a bar graph and show unitary method to solve. Okay, so there's my ratio of cement to sand. I have 5 units of cement for every 3 units of sand. And I have 30 buckets of sand, so 3 units are going to equal 30, 1 unit equals 10. We divide that out. Now I want to solve for 5, and 5 units equals 10 times 5, or 50 buckets of cement. Okay, now I want to use the same proportion, and I want to know how many buckets of sand are needed to mix with 30 buckets of cement. So my numbers are reversed this time, but my proportion is still the same. So I'm using the same bar graph with 5 units of cement and 3 units of sand, only this time 5 units equals 30, 1 unit is going to equal 6, and 3 units will equal, oops, I have a mistake on my PowerPoint. Okay, well let's ignore that. 3 units will equal 6 times 3, which will be 18 buckets of sand. Okay, pretend you didn't just see that mistake on my PowerPoint. And there's the real answer for you, all corrected. All right, so here's another table. Go ahead and take a second and fill in those missing numbers. Okay, so if we are looking at the proportion of Jell-O crystals to cups of water, we can see that the proportion is 1 to 2 crystals to water. So if I have 1 cup of crystals, I will need 2 cups of water to make Jell-O. If I have 2 cups of crystals, I would need 4 cups of water. How many cups of Jell-O crystals do I need with 16 cups of water? I'm going to need half of that, or 8. If I have 16 cups of Jell-O crystals, I am going to need, you should see by now, double that, or 32 cups of water. So the ratio of Jell-O crystals to water is just going to be 1 to 2, which also happens to be the proportion. So remember, the proportion is just the simplified ratio. So I wouldn't say the proportion is 16 to 32. I would always just say that the proportion is 1 to 2. All right, so Wendy mixes 1 liter of juice concentrate with every 3 liters of water to make a drink for a party. Let's start by drawing a bar graph. Okay, looks like I have water on top, which is a little bit confusing because juice concentrate comes first in my word problem, but let's just go with the flow here, guys. Okay, so letter A says, draw a bar graph. There's my bar graph. You should be copying this in your notes. Letter B says, find the ratio of the amount of juice concentrate to the amount of water. So I want juice to water, and my ratio is going to be 1 to 3. If I reversed that and asked you what the ratio of water to juice was, I hope that you would tell me it would be 3 to 1. But a ratio is always in a certain order, and we need to read the word problem carefully to make sure that we have the order correct. To make the same drink, how many, oops, I have another typo. Okay, fixed it. How many liters of water are needed to mix with 6 liters of juice concentrate? We need to keep the water and juice in the same proportion. So remember, my juice to water was 1 to 3. So I've already got my bar graph up there. It's the same bar graph that we just used, only you're going to copy it into your notes again. But now I want to use unitary method to solve. So I've already got my unit there, don't I? I have 6 liters of water. So that's my 1 unit. Now I want to solve for, I'm sorry, it was 6 liters of juice. But I want to solve for water. Water has 3 units, so I'm going to multiply 6 times 3 and get 18 liters of juice concentrate. Okay, letter D says, to make the same drink, how many liters of juice concentrate are needed to mix with 15 liters of water? And then, of course, we're going to draw our bar graph and show unitary method to solve. Okay, so this time, my 3 units of water equal 15 liters, and we want to solve for juice. Okay, so we will need to take that 15 and assign it to the 3 units, and now we're going to divide 15 by 3. So we get 1 unit equals 5, and now to solve for juice, I'm pretty much done. I just need to add a liters unit label to it, but 1 unit equals 5 times 1, which equals 5 liters of juice concentrate. You guys see how useful proportion is? Imagine what you could do with a recipe. Okay, now we have Mr. Ray, and he mixed red paint and blue paint in the ratio of 3 to 2 for a painting job. What is the proportion? And we want to draw a bar model. First of all, what's the proportion? Just go ahead and answer that question out loud. Obviously, it's going to be 3 to 2, right? Okay, I hope you guessed that. So go ahead and pause the video and draw your bar graph, and then solve with the unitary method and come back and check your work. All right, hopefully you drew a bar graph like this where red paint has 3 units and blue paint has 2 units. Okay, so letter A says if he used 12 liters of red paint, how many liters of blue paint did he use? So our 3 units is going to equal 12. And we want to know how many 2 units equals. So 3 units equals 12. We'll solve for 1 unit. 12 divided by 3 is 4. And now we're going to solve for 2 units. So 2 units equals 4 times 2, or 8 liters of blue paint. Okay, now what happens if Bob, oh no, this is Mr. Ray, not Bob. But what happens if Mr. Ray used a total of 10 liters of paint for the painting job? Now remember, our proportion is still 3 to 2, but we're changing up the amount of liters that he used. So the units are going to change a little bit. Okay, so he used a total of 10 liters. How many liters of red paint did he use? So let's solve for 5 units. 5 units equals 10, and I'm using 5 units because we learned that he used 10 liters total for the painting job. So 1 unit is 10 divided by 5, or 2. Now I'm going to solve for 2 units. I take it back, I'm solving for 3 units because we're solving for the red paint. So 3 units is going to be 2 times 3, or 6 liters of paint. Okay, we have another one. You guys should probably try this on your own and then come back and check your work. Okay, Cole mixed chocolate, vanilla, and milk in the ratio of 1 to 4 to 7 to make 6 liters of chocolate milk. So remember that when we're reading a word problem, we're going to our ratio is going to be read in the same order as the word problem. Okay, so if you mix chocolate, vanilla, and milk, that means chocolate has, in the ratio of 1 to 4 to 7, that means chocolate has 1 unit, vanilla has 4 units, and milk has 7 units. So when it says he made 6 liters of chocolate milk, that means all of the units together equals 6 liters. Okay? So now we want to know how many liters of milk did he use. And I think it looks like my 6 liters is getting cut off on my screen, but hopefully you guys mark that on your notes that all of the units together equal 6 liters. So let's solve using unitary method. And I have 12 units all together, so that equals 6 liters. 1 unit is going to be 6 divided by 12. Ooh, that's tricky, isn't it? That's a fraction. So I could reduce that and say 1/2. Now I want to solve for 7 units. So 7 units is going to equal 1/2 times 7, which would equal 7 halves. And if I change that to a mixed number, it's going to equal 3.5 liters of milk. All right, friends, I think that those are all of our problems. So your homework is going to be workbook exercise 12. And that's it for ratios day 9.